I am Johann Steff. This is Isotrona, the source of creation. In today's video, I'm going to try to generate electricity with two forks, a candle, and a piece of aluminium in between the forks. Okay, so this is the theory, and it's actually very simple. You need to have two different types of metals. On the sides here, I have iron, I have placed iron, and in between them, connecting the two sides, okay, I have a copper wire connecting the two. Over here, where the wires meet, these places are called junctions or bridges, and you need to have a cold side. This is a thermoelectric effect. You need to have a cold side, this side would be cold, and a hot side, a part that gets heated. Okay, this is where the candle would be lit. Okay, and this difference, this thermal difference between heat and cold, okay, would generate electricity in the form of a positive and a negative or minus. Okay, so this is the setting. I took a piece of aluminium like this. Okay, I wrapped it in four, actually in two. I believe, yeah. I wrapped it in two, then passed it through the fork. I mean, I pressed it just against the tip of the fork. Okay, so yeah, and I've done the same on this other side. This would be the cold side, this would be the hot side over here. Okay, so underneath it I placed the candle like so, like this. Okay, so I hope it's right underneath it, because okay, I have to place it right on top of the tip of the flame, because the tip of the flame would reach 1200 degrees, whereas the sides of a natural draft fire, the sides would reach 600 degrees, and the tip would be as high as 1200 degrees Celsius. Okay, so this is the cold side, this is the heated side, and I'm going to do now a test. You can see that the multimeter, I set the multimeter for the sound test over here. Okay, so I'm going to do a test just to see that electricity passes through the fork and through the aluminium. Okay, so yeah. Okay, so I'm pretty much ready to start the test now. What I've done is I've connected the alligator clip on this fork, okay, on the fork that's going to be heated, on the heated side, and I've changed the multimeter from the test function to measure the direct current. And I've set it to 2000 millivolts. Hopefully it will generate a few that would be detected. Okay. So now all I have to do is light up the candle. Okay. Hopefully we'll have a reading. Okay, so the candle is lit. It burns. Okay, and hopefully it will start to show something. Yeah, we already have, actually it's negative, it's minus 001, just a bit. I hope it will go higher than that. I hope it's underneath it. Oh, I'm not sure about that. Well, it is. It does seem so. Like so. Okay, so it's minus 002. It's not much, but it's something, just to prove that actually it works. I hope it will go higher than that. This is a very low voltage. Oh, minus 0.003. Okay, so it's increasing. Why did I choose the forks? Because the forks have a large surface area. If you are to try to test the thermoelectric effect, it's best that both the heated side and the cold side have a large surface area, contact area. This is somewhat low. I mean, okay, it spiked. Okay, no, it spiked to minus 0.004. So 4 millivolts. That is 0.004 volts. It's kind of low, but it can be perfected to go higher than that. Not much higher, but yeah, it could reach a few volts. This is a proof of concept, just to show that it actually works. Okay, so we have now a steady 4 millivolts. Back to 3. I might have blown on the... Okay, actually the candle doesn't... the candle stopped burning, okay? So the fork is still heated, okay, and is generating the 3 millivolts due to the fact that this fork is very, very heated, okay? Very hot, warm, actually more than warm. And this one is very cold, okay? And it's now dropping. As it loses heat, okay, the voltage actually drops. And I'm going to continue actually the test with some copper wiring, see if it performs better. I believe it will. Okay, so I'm now going to take some copper wiring, strip these wires, okay, with this stripper clipper. Yeah, I'm going to strip some wire, wrap the wire around the forks in the same setting, okay, and see if copper can generate, or the combination between. Actually, the forks are stainless steel, are made of stainless steel, and stainless steel is actually mostly iron, and it's stainless because it's alloyed with chromium. Okay, so yeah, that's what I'm going to do. I'm going to now test the forks with some copper instead of aluminium. Okay, so I took the forks off, and this is how the fork that was exposed to the heat looks like. It accumulated some tar on it. It's black. I think I'm going to use some rubbing alcohol for the next test. Okay, so this is how the new setting looks like. As you can see, I've woven the copper around the forks, so they are they have a large contact area. So it's woven like a fabric. Other than that, I no longer have the candle. I placed some rubbing alcohol as a heat source. Okay, and what I'm going to do, I'm going to try to protect the heated side, or the warm side, or the hot side. Actually, this time it's only for the protection of the copper, so the copper won't get oxidized, because if it develops a layer of oxides or it interacts with the air and it develops a layer of oxide on top of the copper, then it loses conductivity and it will stop driving electricity. Okay, so I wrapped the hot side in aluminium, and in case you wonder if the same was not the case for the aluminium setting, the first test that I've done, the test that I've done before. Okay, yes, so aluminium quickly develops a layer of oxide on top of it as it gets heated, but not so much on the inside, because on the inside it lacked oxygen, so it wouldn't develop a layer of oxide, a non-conductive layer. Okay, so I'm going to light it up. Like so. Okay, so it now burns. You can see it burns. And it will take a while. It should take a while. Okay, so we already have a reading of 1 millivolt. I hope it will go. Okay, it's 2 millivolts now. And some people will get higher than that. Okay, so 3 looks promising. Come on, you can do better than that. It's still burning. It's a steady 3 millivolt. Stabilized there. Okay, so as the fire gets dimmer and smaller, okay, so does the voltage. You can see it drops. It dropped from 3 millivolts to 2 millivolts. Okay, the fire is just weaker and weaker. And I could just blow it out now, like so, like this, okay? And it should go Fork is still heated. Okay, it's now 1 millivolt. Okay. Okay, so the thermoelectric effect does produce small amounts of electricity, despite the fact that it would take 400 forks in this setting to generate as much electricity as a 1.5 volts battery produces. I'm convinced that this effect, the thermoelectric effect, is promising, and it can be developed into a promising technology. If you enjoyed this video, be sure to subscribe, like, and even save this video.